Okay, so you're looking at functions, and the first thing for us to do if you want to understand functions is to know what relations are. Now in the relations, we have 4 types of relations. The first one looks like this. So you can see that each entry of the left side goes to a unique entry of the right side. So we call this a 1-to-1 relation. 2, we also have structures where this is 1, 2, 3. That is 4, 5. This goes there. This goes there. And this goes there. Because 2 elements are going to 1, it will be called a main to 1. Still a relation. We also have a situation where 2, 3 going to 5, 6, 7. This guy goes there. The same guy goes here. And this one goes here. Because 2 goes to 2, we'll say 1 has gone to many. And the fourth one, we have 2, also have 3, 5, 6, 7. This goes there. The same guy goes there. 6, when 2 goes to 6, and 2 goes to 5. What it is now is that 1 is going to many. Also, many going to 1. We have 2 and 3 going to 6. We also have 2 going to 5 and 6. So it's a balanced state, many to many. Okay, at this point, we can define a function. A function is a rule that relates each element of the domain to a unique element of the range. Where I say range, I can say image. Let's look at this now. A function is a rule that relates each element of the domain to a unique element of the range of the image. Let's go back to 1. Is 1 a function? You will notice that each element of the left-hand side of 1 goes to a unique element of the right-hand side. So that this guy is a function. 2, each element of the left goes to 1 element on the right. Now, what we mean by unique here, how does the unique come into effect in 2? The fact that 1 goes to 4 satisfies the 1 going to unique 4. 3 goes to 4, satisfies the 2 going to a unique 4. 3 goes to 5, a unique 5. So this is still a function. The word unique is telling us that we must make sure that there's only one arrow from the left to the right. From each element, the easiest way of knowing whether it's a function or not, you go and count how many arrows are leaving one number of the left going to the right. If you find that there are 2 arrows, like in situation 3, where from 2 we have an arrow going to 5, an arrow going to 6, then not a function. The same story here, not a function. These are questions that are frequently asked in an exam. They will ask them in this form. Examples. 1. If f is 1, 2, 3, 4, 5, 7, 8, 11. 1. Represent f in an arrow diagram. 2. Is f a function? 3. Find the domain and range of f. Find the inverse of f, stating the domain and range of f inverse. And here, state the relationship between f and f inverse. Okay, so we have f is given as an ordered function. The solution 1. Represent f in an arrow diagram. First thing, an arrow diagram is of this form, where you get the elements of the left 1, 3, 5, 8. You get the elements of the right 2, 4, 7, 11. And get the arrows. So move from 1 to 2, from 3 to 4, from 5 to 7, and from 8 to 11. Call this guy F. So just put F in between there. That is an arrow diagram. You're done for an arrow diagram. Two, is F a function? Yes. By definition, each element of the left is uniquely related to an element of the right. If they ask you to state the nature is it's a one-to-one function, meaning it falls under a one-to-one relation. Three, find the domain. The domain of this type of functions, you get this set here is what you call the domain, the X values. So it will be 1, 3, 5, 8. So the range, the Y values. So it will be 2, 4, 7, 11. That's all. So we're learning the properties of this function here in this example. 5, find the inverse of F. To find F inverse, in these types, we don't solve. You just go to the same F and you switch. Instead of saying 1, 2, you say 2, 1. Instead of saying 3, 4, you say 4, 3. Instead of saying 5, 7, you say 7, 5. Instead of saying 8, 11, you say 11, 8. You're done. That's the inverse. State the domain. The domain, the left entries. So this time around it will be 2, 4, 7, 11. And the range, the second entries, 1, 3, 5, 8. 5, state the relationship. This is where now we become serious. So we say, okay, how do these guys relate? We've seen that the domain of F, this one, domain F, range F. Domain F inverse, range F inverse. The domain of F is the range of F inverse. And what else? The domain of F, as you can see, the domain of F goes where? Comes here, is the range of the inverse. And the domain of F inverse is the range is the range of f. Let's check. The domain of f inverse is the range of f. Very, very cardinal. This is what makes us, in some other types of functions, when they ask us to find the range of a function, we solve for its inverse and get the domain. It's because of this. It's always because of this. This is where it starts from. Okay? So, these same type of functions, they also have got composite. What do we mean by composite? If f is 1, 2, 3, 4, 5, 7, and g is 2, 8, 4, 9, 7, 10. Let's say 1, find g of f. 2, domain and range of g of f. Three represent on the number line. No, represent on the arrow diagram. Okay, let's see solution. So I want to explain now what we mean by composite for these functions. So we're looking for one g of f. G of f is the same as you get g. In g, you take f. Now, if you're dealing with ordered pairs, what you do is immediately you see such a question, go for f, get the first entries of f, make them your first entries in the composite. So there will be 1 here, comma, you close. There will be 3, comma, you close. There will be 5, comma, you close. Okay, that's why I'll get to that. So you want to get the relationship in this sense, g of f. So first thing is you go to f, get the first entries of f, and make them your first entries of the composite g of f. Then now, how do you get the second entries? You go to 1 in F, it goes to 2. You don't put 2 in the composite. You go to 2 in G and see where it goes. It goes to 8. So here we'll put 8. You go to 3 in F, it goes to 4. Follow up 4 in G, it goes to 9. Here you put 9. You go to 5 in F, it goes to 7. 7 goes to 10. Here you put 10. That is how you get this composite structure. Now, what is it by definition then? If this is how you obtain it, then what is it? So a composite function is a function that is obtained with respect to the relationship or the conditions attached to it. So, okay, let me put the definition after the third piece. The second piece, find the domain and the range. Now, after you get it like this, what is the domain? We say the first entries form the domain, and the range, the second entries form the range. 3, an arrow diagram. So of the answer, it's very easy. You just say 1, 3, 5, and 8, 9, 10. This guy goes there, this one goes here, and this goes there. That is G of F. If they ask you to show the relationship, the solving on the arrow diagrams, you do this where you get F, that is 1, 3, 5. And then the second piece of F, 2, 4, 7. And then the third one, you don't get G. Since G is starting from 2, 4, 7, you just get the remaining part, 8, 9, 10. Here we are saying F moves 1. So F moves 1 to 2, and then G moves 2 to 8. So 3 to 4, then 4 to 9. 5 to 7, then 7 to 10. So ultimately, we want to get this first one and the end one. The first one and the end one. The first one and the end one. That is what forms the composite. So that's how we obtain it. Is it okay? So what is happening now is this type of function is not that common. It's not studied that much, but it appears in the exam. That's why I have given an example of the composite. So now I'll give another one. But before I give another one, we'll give a statement. We say a composite function g of f is a function that maps the entries of f to the entries that maps the entries of f to the corresponding entries in the output of G. So it's a function that deals with the relationship of two functions with respect, with an emphasis that the strictness is coming from the inner one. The inner function is what holds the outer one. So the inner function is the domain of the outer function. Where the inner function fails, the whole function fails. So I give another example. Example 2. If f is equal to 1, 2, 4, 8, 7, 14, and G is equal to is equal to 3, 1, 9, 4, and 11, 7. Find f of G. Let's see. What will be f of G? F of G would be f with G inside. Meaning, we go to G and get 3, get 9, get 11. Then go to F now. As we start from G, we follow 3, goes to 1. Come to F, 1 goes to 2. So 3 will go to 2. 9 goes to 4. 4 goes to 8. 9 must go to 8. 11 goes to 7. 7 goes to 11. to 14. So this guy goes to 14. Now this directly tells us that the day you find that 3, if it was 3 goes to 10, you have 3 here, you follow it up, it goes to 10. You come to F, there's no 10 in the left entries. Immediately you have such a situation, you say f of g is undefined. F of g will fail to be defined at that point. Do we have questions on this type of function?
So I have a question.
Please ask.
Since it's f of g, so meaning when writing down your functions, you first start by listing the f before you go to the g.
You start by listing the g before you go to the f.
Or you start with the one that's in the brackets, the g.
Yes, the g.
So if it was g of f, would have started with the f.
Yes.
First.
If it was g of f, you start with the f. And which part of the f? The x entries of the f.
That's f. Okay.
Yes.
Thank
you. Sir, kindly repeat when the undefined part.
So the undefined part is, since we start with the entries of g, if when you follow the entries of g, where they are going, for example, they are going to 10, if you get 3. 3 goes to 10. You need to follow 10 in f. Now you find there's no 10 in f. Because there's no 10 in f, the function is undefined. F of g does not exist. Find f of g. Domain of f, domain of g, and domain of f of g. Three represent on an arrow diagram. Okay, so I'm going to send you this as a PDF, even if you haven't copied the question, because time has run out. So for today, we won't log again. So I'll give you time, you work on this. I'm told there will be a power cut.